Hello folks, this is Mike coming back at you with another video on Intro to Algebra. In the previous video, we wrapped up talking about scientific notation. In this video, we are going to begin to talk about a new type of algebraic expression, one that we are going to be talking a lot on from here on out for the rest of the course, as well as in higher level math classes as well. And those expressions are referred to as polynomials. A polynomial, and we specify in x, saying that x is the variable. It is either a term or it's a sum of terms where each term is of the form a times x raised to the nth power. A can be any real number whatsoever, but we are going to be really working with integers here, and n is any whole number. So to be clear, that is a non-negative integer. Sorry about that. So 0 or higher, 1, 2, 3, 4, 5, so on and so forth upwards. So these are some samples of polynomials. 5 times x to the fourth minus 2 times x cubed plus 10x plus 7, or minus x to the sixth minus 4 times x cubed plus x squared minus 11x plus 1. Some examples of things that are not polynomials. 3x squared plus x plus 1 minus 2 times x raised to the power of negative 1. This is not a polynomial because of this exponent right here. We can't have an exponent that is less than 0 inside of a polynomial. So that right there makes this not a polynomial. Another example of something that's not a polynomial, x to the fifth minus 3x cubed plus x plus 10 divided by x squared. If you're seeing variables in the bottom of a fraction inside of your algebraic expression, then this thing is not a polynomial. Right there, not good. So these are two examples of things that are not polynomials. So some basic but important terminology that I want to clear up that relates to polynomials. We commonly write these things so that the terms are written so that the term with greatest exponent on x is written first, then the term with next highest exponent is written second, next highest is written third, so on and so forth. When we write our polynomials like this, we say that the polynomial is written in descending order of power. And I've written a polynomial here, and this is in descending order of power. We see that the highest power on our variable x is in the first term that's written here. Then the next highest power is in the second term. Next highest is in third term, so on and so forth, all the way down. And when we write our polynomials in descending order of power, the first term is called the leading term, and the coefficient that's in that leading term is called the leading coefficient. The exponent on x in the leading term is referred to as the degree of the polynomial. So just some basic key terms here, things you will want to know, especially when you go on to take higher level math classes, because you're going to see that these things do give you some handy information about what the graphs of these things would look like. So we are going to identify the degree and the leading coefficient of each polynomial below. So first thing you have to do is check to see if your polynomial is in descending order of power. If it is, then you just have to look at the first term. If it's not, then you have to carefully look through and find the term that contains the highest power of x in it. That term is the leading term, and that's the term that you need to look at. So to start off here, negative 7 times x to the fourth plus 3x squared plus 7x plus 9. I look at this polynomial, and I see that it is in descending order of power. You have the term with highest power listed first, next highest power listed second, next highest third, and then the other term last. So I know that if it's in descending order of power, I just have to take a look at this first term here. The degree is the exponent on the x, on my variable x. That exponent is 4, so that tells me that the degree is going to be 4. And the leading coefficient is going to be the number that is in front of this x with highest power on it. And the number in front is the negative 7. So that's going to be my leading coefficient. All right. I'll let you try the second one on your own, but we'll move on to the third one here. 4 times x to the fifth plus x to the third plus 10 times x to the seventh minus 5x squared minus 4. Is this polynomial in descending order of power? No, it's not, because here I have an exponent of 5, then I have an exponent of 3, then I have an exponent of 7. So we don't have our term containing highest power of x listed first. So that tells me that I can either put this in descending order of power, or I can just highlight or underline the term that contains the highest power of x. I'm going to choose to highlight or underline the term that contains highest power of x, and as I look at these terms, I see that it's the third term right there that contains the highest power of x. So the degree is going to be just that highest exponent, that highest power that we have, which is 7. And then we have the leading coefficient, which is the number in front of that x with highest power, and that number is 10. So that is my leading coefficient. As I said, I'll let you try this guy on your own, and we'll go through it in class. I just want to give you some special terms for some particular polynomials because they do have their own names. If you have a polynomial that only has one term to it, it is called a monomial. Mono, one. A polynomial with two terms in it is called a binomial. Bi as in bicycle, two. And a polynomial with three terms in it is referred to as a trinomial. Obviously, triangle, 3. If your polynomial has any more terms than that, there's really no name that we have for it. We just call it a polynomial. So recall that we can evaluate algebraic expressions, and thus including polynomials, at a specific value. You take the number that you're given and you substitute it in for the variable and you see what you get according to the order of operations. I'll let you try the first one on your own. We'll go through that in class, but we'll do the second one here very quickly. I have 3x minus 1 plus 2x to the fourth minus x to the sixth, and I want to evaluate this at x is equal to negative 1. So I have 3 times negative 1 minus 1 plus 2 times negative 1 to the 4th minus negative 1 to the 6th. And you guys can use order of operations, or you can utilize your calculators. 3 times negative 1 is negative 3 minus 1 plus 2 times negative 1 to the 4th is going to give you a positive 1. So plus 2 times 1 minus, and negative 1 to the 6th power is going to be a positive 1. So minus 1. So I have negative 3 minus 1 plus 2 minus 1, and that is equal to negative 3. So as I said, try the first one on your own. We'll go through that in class. Now, the other big thing that I want to talk about in this video, adding or subtracting polynomials. Adding and subtracting polynomials is very straightforward. Basically, it is essentially just combining like terms. When we add two polynomials, we combine, as I just said, we combine or add or subtract the like terms. When the operation is specifically subtraction, though, we have to change the sign that's on each term in the polynomial that's listed second, and then we'll add this result to the polynomial that is listed first. So, go through some samples here. First one, I'm going to add 5x cubed minus 2x squared plus 5x and 2x to the 4th plus 3x squared minus x minus 1. So, I need to identify what terms, if any, are like terms. So I'm looking for terms that have the same variable and the same exponent on the variable. Okay, I don't see any other x cubed here. Do I see any other x squareds here? I see an x squared and I see an x squared. So I can combine those things. I see an x and I see an x. So I'm going to combine those guys. I don't see anything else with an exponent of 4, and I don't see anything else with anything else that's just a number, just a constant. So when I write this, and again, we're going to write this the way that we typically do in descending order of power. So my highest power showing up here is 4. So it's going to be 2 times x to the 4th. Next highest power is, we see here 3. So it's going to be plus the 5x cubed. I have some things with a power of 2 that I can combine. I have negative 2x squared plus 3x squared. That gives me plus 1x squared, or just plus x squared. I have a plus 5x, and I'm adding a negative 1x onto it, or subtracting 1x from it. So that gives me plus 4x. And then I just have the minus 1. So nothing too crazy there, nothing too complicated. I'll let you try the second one on your own. Let's move to some subtraction now. So when we're subtracting, as we said, we have to change the sign that's in front of each term in the polynomial that's listed second, and then we'll take that result and we'll add it to the polynomial that's first listed. So right now I have a plus, a minus, and a minus. And So that means when I change the signs, this will be a minus 3x squared plus 5x plus 2. And now we're adding. So now we are just literally combining like terms. I see this term has an x squared, this term has an x squared, so I can combine these two like terms. 2x squared plus a negative 3x squared is a negative 1x squared, or just minus x squared. I have an x plus a 5x to give me 6x, and then I have a 1 plus a 2 to give me 3. So there was one more problem there at the bottom of that page, which I'll let you try on your own. We will go through that problem in class right here. But now I want to move on to something a little bit more involved, just a couple sample problems here, where we have a polynomial in x and y. It's not something that you're going to see very often, but it can come up. But again, there's really no different method that you have to use. It's the exact same method. You just have to be a little bit more careful about what terms are like terms. So I'm going to go through the more difficult one, the more challenging one, this one here. I'll let you try the top one here on your own, and we'll go through that in class. So we see that we are subtracting here. So again, change the sign in front of each term in the second polynomial that's listed, and then add that result to the first one. So it's going to be x squared times y squared plus 6x plus 4xy plus 2x squared y squared minus 3y minus 6x. Minus plus plus became plus minus minus. And now we're adding. So do we have a term that is like this term? Well, yes, we do. We have this term right here. Both the x and the y have an exponent of 2 on them. So I have 1x squared y squared plus 2 more x squared y squareds to give me 3 x squared y squareds. Okay, do we have any other term that is like 6x? Not there, but here we do. We have just an x, so I can combine these things. And plus 6x minus 6x, those guys nicely cancel out to 0, so I don't have to write anything. Do I have a term that is like 4xy? No, so I just copy that down. And then do I have any term that's like minus 3y? No, I don't, so I just copy that down as well. So this is how you add or subtract polynomials. Again, nothing really crazy. It's just more practice with combining like terms. That concludes our video on section 4.4. In the next video, we are going to talk about multiplying polynomials, something that is going to be very, very, very important for you to know how to do, not only in this course, but in subsequent math courses as well. If you have any questions or comments, please reach out to me, guys. Ask me questions in office hours, via email, over the phone, in messages sent by carrier pigeons, whatever. Until the next video, take it easy, guys.